All right, good evening, guys. I believe you're doing fine. So welcome again to Python with Data Science with Python. Okay, so I'll be taking you through, I'll be your tutor. My name is Peter Ataigo. And yes, it's going to be an exciting journey. So we're going to start with an introduction. So we're going to start with Python basics and the syntax. But first of all, what is Python? So Python is a high level and a general purpose programming language known for its simplicity and its readability. So now I want you to take this, when you hear Python, I want you to take it as a normal language that we speak just the same way that we have our English language, we have our French, we have Spanish that we use in communicating. So Python is actually a high level language in the sense that it has its own interpreter, and also the English, the syntax actually like human related, so you can actually relate to it. So Python helps us to communicate with the computer. So you have a task to do, you want to write a program, which is a set of instructions. So you can actually use Python to write a program to get something done. So of course we know, we've actually know some of its applications in data science or machine learning, which is our focus for this course. And then it has application in web development, in automation, and in game development and AI. So you should be aware that you're actually learning a powerful tool that can carry out a lot of awesome tasks. Yes. So we'll start with the basic syntax. So we'll go through this, then we'll go to the Jupyter Notebook to run some of this code so that I can say it live. So I'll be explaining this, so please pay attention and then get it. So we have variables. First of all, what are variables? So variables in Python are like, when I mention variables, they are what we call containers. You can see them as a container or a namespace where we get to store things in the memory of your computer. So for example, now when we say x is equal to 10, so x here is your variable. X is a variable, and then we are assigning the value 10 to x. So what Python does is that whenever you write a line of code like this, x equal to 10. Now, so what Python does is that it's going to create in the memory of the computer, it's going to create a space and they name it x. So whenever you call the name x, what will be printed out would be the variable that is stored in it. Now, though I said equal to, but this actually means assignment. So we are assigning 10 to x. In normal mathematics, when we say x is equal to 10, that means we are comparing both sides and we are saying the variable x is actually 10 when we solve in mathematics. But in Python, what we are saying is that we are assigning the value 10 to x. And also we have another example here, name is equal to John. So John now is a string, and that's why you see it's in quotation mark here. We'll come to that. And then now we are assigning the name John to the variable name. So it is good practice that you give your variables, standard names, so that you can actually remember what it's actually containing. Good. So if, for example, you want to, have a variable that actually holds the age of students, so it will be good practice to name the variable age. But if you just name it A, later in the later time, you might forget what that variable A is actually containing. But if you say age, it's easy to remember. So it's good practice that your variables actually hold the meaning of the data that it's containing. So also, how do you name a variable? They're actually rules, right? So we have what we call syntax and we have semantics. So syntax like the rules that and the words and how we can program in Python. So because in just like in English language, when you're done with a sentence, you put a full stop. So same thing with Python, that it has syntax that has to be followed. So when we say x equal to, so this is a syntax that we're following. So like this quotation mark here, it's a syntax that we are following. Yeah, so for you to name your variable, there are also some rules. So you cannot start with a number. Your variable cannot start with a number. You cannot say 1x is equal to 10. You can't start with a number. You can only start with a letter or an underscore. You cannot start with a symbol. You can't start with a full stop. You can start with a comma. You can only start with a letter or an underscore. So you can actually include a number later in the name. So you can have x1, x2. You can separate the letters using underscore. You cannot also have spaces. Your variables cannot have spaces. You can also use, I think only $sign is allowed also when naming your variables. So we also have what we call comments. So comments are a way of actually documenting your code, of explaining your code without it running in the output. So when you want to just maybe put in some things in order for you to understand your code, because there are times when you write a lot of codes, like running to hundreds of lines, thousands of lines, and sometimes after years, if you're not careful, you can forget some of the things that have been done there. So comments are a way of actually properly documenting your code. One, that's one of the use. And also, whenever you send your code to somebody, they can actually read through and understand your code. So we have the single line comment. That means you just want to put a comment for one line, and we have the multi-line comment where you want to write, more than one line. So we use the three dots. So for the single line comment, you just use the hashtag. So whenever you put a hashtag, whatever comes after the hashtag, Python sees it as a comment and it doesn't run that line. You can only see it, so it omits that line. So the same thing it does for multi-line comments. Whenever you put a three quotation mark, three single quotation mark, or you can also use double quotation mark, three of them, and end with the same quotation mark. So whatever is in between that block, Python sees it as a comment and it skips it. So we have data types. So in Python, so of course there are different, just like we have variables that stores information. So this information have different types. We'll talk about data types. So when you want to store, an integer value, integers now are whole numbers. Floating points are decimal numbers. So when you want to store these values in the variable, so Python has a way of creating space, because it does it automatically for you. So when you say x is equal to 10, Python knows that x is an integer variable because 10 is an integer. So it creates the required space for it. So just to to manage your space, or to properly make use of the space in the memory. Yes. So also we have strings. So we just have to say your name is equal to John in code. So that's a string. So whatever you put in code, Python sees it as a string. So that's a syntax for writing string. And then we have the Boolean, which is either true or false values. So we can actually run arithmetic operations that we can carry out on some of these data types. So it could be addition, subtraction, multiplication. This is how Python says multiplication. This is division. This is the remainder after a division. So we're going to see how it works. This is the power. So this is saying A raised to the power of B. So we also have a print statement. So print statement is a way of outputting a line of code, or outputting something to the user. So if you have print hello world, so whatever is inside this print statement is being printed out. So when you put it in quotation mark also, it prints it out literally prints it out. So whatever is not in the quotation mark, like this name here, Python sees it as a variable. So if it's not in a quotation mark, Python sees it as a variable. But if it's a quotation mark, Python prints it out literally. So we can actually we now have strings. So but before we go to strings, let's go to our Python notebook and then see how some of all this works. All right, so we've seen where we assigned x to, we assign 10 to x, and we assign John to the variable name. And so when we print this out, a very simple print statement, this is making use of the literal. So a very simple print statement would be something like this. So we want to find out what is actually inside the variable x. So when we run this, actually, so for you to run your variable, okay, after this, you're supposed to put a comma. So you see, Python doesn't forgive whenever you omit something. So you need to understand every syntax, and so that you could actually obey them. So we have this. So what this does now, when we look at this line of code, what this says is that now it prints out literally x is equal to, whenever it's inside a quotation mark, it prints it out literally. And then we added the comma because we want to also what is coming next is actually a variable. So if this variable was never mentioned before, now it's not stored in the memory, Python is going to print out an error and say the variable y, the name y, is not defined. So because here I used y when I've not actually defined my variable y. So that's how it works. So when we see what comment does now, so whatever I put in front of an hashtag, Python says as a comment. So this is a comment. So Python doesn't run this line. So whatever I can add anything to this line, and then it doesn't run it, and then it's just prints out whatever I added at the end of the day. So if you don't add a print statement, if I comment this out and there's no print statement, Python just stores this and does nothing. So the print statement is like it taking an action on that variable that has been stored there. So this is x is equal to 10. So take note that even spaces are counted. Look at there's an extra space between the equal to and the 10 here. So when I take this out, the space will be reduced. So Python also, you can also, it print that's that whatever is literally in that quotation mark, it prints it out. So we have our single line comment and our multi-line comment. So this tells us that this is a multi-line comment. And then for the data types, so we saw the numeric, you have the numeric data types, which include the integers and floating point numbers. And we clearly differentiated them by saying that the integers are the whole numbers. That means they don't have decimal points, while floating point numbers are the ones with decimal points. So when we have, 5.5. So this is a floating point number. And then we can actually find out the type of the floating point number when we just actually print out a very simple thing like this, like type. We can say print okay, this is actually Jupyter, so it will forgive us if I didn't really introduce you guys to Jupyter. So actually Jupyter is actually an IDE where we can run our Python codes. So we have what we call the markdown cells and we have the code cells. So when I put it, you can see at this top, we have the markdown. So markdown are actually used to help, beautify your code, to make it, look good and, readable to the eyes, because sometimes just adding codes and comments alone are not enough. So you can actually add something. So I intentionally made this yellow so that you can see orange, so that you can see that you can do a lot. So you can use, if you're good with HTML, you can add it here to your markdown code. You can, if you're good with LaTeX, you can add it here. And so this actually helps your work to be beautiful. So when we come here, now when I said Jupyter can actually forgive us. Sometimes you can just put in the value X here without the print statement, and it will print out the value 10, because already it actually has it automatically knows that, okay, you want to output the value 10. So when I put the type, so what is the type of, let me run this code. What is the type of this integer num? So it's going to tell us the type. So you see that the type is an integer because there is no decimal point. So, but when I say give me the type of floats, so it gives me that, okay, this variable that is stored in float num. Float num now is the name of a variable. Remember I said how we name a variable is that you start with a letter, you don't start with a number. If I add the number here, Python will flag an error because I'm not allowed to start with the number, only a letter, and I can separate them by using an underscore. So I can't put a space between my numbers, my variables. So there should be no space. And also, you make sure that I said it's good practice that your variable name actually holds the meaning of the variable that it's containing. So when you see float num, automatically you know that, okay, this means a floating point number. So that's how it works. And then when we run this, so we can see that this is a floating point number. And also we have string, another data type, which is called string. And I say that for you to actually, create a string, whatever you put on inside, a quotation mark, Python sees it as a string. So you can put hello world, the usual way we start, learning any programming language. So hello world, to print hello world. So we are assigning this text hello world now to the variable text itself. So it could be a sentence. You can name this a sentence, you can name it whatever. So now when you do this now, so Python creates a space in its memory and then, assign it towards hello world. Everything inside hello world is printed literally, including the space that is added. So you can also put a number. It doesn't, flag an error. So when we do this and we run this, it does nothing. So it does nothing because I've not called the print statement. So the moment I call print, and I say text. So what is inside the variable text.
Oh, was I touch something?
And 1. So
I plugged it on my this installed, but I plugged it
to the socket. So we say hello world. It didn't come and print it out literally.
Check if I'm on something there or it's supposed to be from socket.
Mute your mic. All right, so we have hello world printed out literally. So now whenever we want to print out something, now attached to
Sorry.
this hello world, so we used what? We use the quotation mark. Now you can use double quotation mark or single quotation mark, as long as when you started it with a single quotation mark, you end it with another single quotation mark. Or when you start with a double quotation mark, you end with a double quotation mark. So Python will flag an error when you start with a double quotation mark and end with a single. It has to be start with the same and then end with the same. So we can say, this is my test program. So you're just telling Python to do this. And then remember, after you print, whatever is inside the quotation mark, you must include a comma to separate what it's printing out literally, and then the variable. Whatever is not in the quotation mark, Python assumes it's a
Why not
variable.
waiting?
So because text is already a variable
Put it
here,
outside.
I won't get an error when I run this.
Sorry, I disturbed
So when I run this like
you.
this, you say, this is my first program, hello world. So you can also use what we call the plus sign for, the print statements. The plus sign is not actually addition. Remember I told you this is like a language. So it has already been, given to Python that, okay, whenever the plus sign is used in the print statement, take it as concatenation. We'll call it concatenation. That means join these weights together. So when I run it, you can see that everything is still runs fine, but the concatenation does not give space. So I need to add my space here. And then when I run this again, you can see that this is my first program. So all of this will make sense when we actually start, running, taking on projects and then carrying out projects. So you can see where all of this can be very useful. So we have the Boolean type. Boolean type can only take true or false. Yes, so zeros or one. So Python also see true or false as zeros and one. So when we say true here, I'm print it out. To print out true. So when I say true plus one, it's going to print out two. So Python sees true as one and then says false as zero. So, but then we actually use it to check if actually maybe you want to check if a particular word is in a sentence. You want to check if a particular letter is in a sentence. So we can actually use this true or false. So that Python can now print out true or false. So for example, if I say, is 5 equal to 14. So now, of course, we know the answer is false. So we can see that, remember I told you that a single equal to is assignment variable. That means you are assigning the value into the variable. Why the equal to we are used to in mathematics? So the syntax is double equal to. So we are actually comparing both sides together. So if I put a single equal to, it's going to flag an error because it will expect a variable to be on this side. But if I put a double equal to, it's going to compare the values of both of them. So when I do this, it's going to print out false. So these are the Boolean types. So it print out false because 5 is not equal to 14. So we have Boolean operators. Of course, we know that's logical operators. That's equal to, greater than, less than, greater than or equal to, less than or equal to, not equal to. So we have all of these. So this is how, these are the syntax work. So it's good practice that you know all of these so that you can actually implement them when carrying out a project. So now we have the following. So we want to, the operations that can be carried out with this variable. So we have A is equal to 10, B is equal to 3. So first thing we can do is addition. So we can add these two numbers together. So we can subtract them, or we can multiply them, we can divide them. We can also, I remember I mentioned that this is the remainder after a division. So, and then exponential means power. So when we do this now, so this print statement is actually a more, should I call it a more advanced way of printing, because it helps you to add both variables and text into your print statement. Remember how I was doing it before? I will have to literally put this in this, a quotation mark and then maybe a comma before the variable, which is actually the basic way of doing it. So all right, so when we run this code, we're going to have this. So we're going to have addition is, look at what happens here now. So we have this F literal. So when we put this addition, so we have a quotation, beginning and then at the end, everything covering it. I mentioned that whenever you put quotation mark in Python, it prints out everything literally, except the things that now for using this f literal, what it does is that you can easily, whatever you put into this curly bracket, it prints out this literally. It prints out literally. So sorry, it prints out it takes out the variable. So whenever you put a now, it doesn't print out a, it prints addition, this column, and then instead of this printing out a here literally, it will print out what the value that is contained, that is stored in the variable a. So if I take this out and then I do something like this, let me run it and see. So we see that, okay, let me add just a to this. So we see that it prints out a literally, a here, without the curly bracket. It prints out a literally. So but when I put it in the curly bracket, so it takes it as a variable. So where to flag an error is if it has not seen that variable. So we have s, so it has not seen, s is not defined. So I need to put a variable that is defined. I had x before, so that's why to run 10. So that's how this works. So this actually helps you to to make your print statement compact, so you can actually use any of that and you'll be fine. So we have now, let's focus on how this operation actually works, the arithmetic operations work. So we know how plus works, minus, the times, now we use the asterisk, the divide we use a single division, and then for the remainder we use for you to get the remainder after dividing, we use this modulo sign, which is the percentage. So we say a percentage b, that means 10 divided by 3 is 3 times remainder 1. So it prints out the 1 for us. And then we have, the exponential. So exponential is just like saying a raised to the power of b. So 10 raised to the power of 3, that's 3,000. So talking about the print statements here again, we've seen that. And then if we have an input now, the name Alice now as a variable, and so we can actually concatenate it using this plus sign or a comma, or as we can see, let me write out all the different ways we could print it out. So we can have the hello here, and then the comma and the name. So it will also work fine. Then we can also have our f literal, f string. When we include that and we say the f, put in your quotation mark. Remember, whatever it starts with, you have to end it with it. So now when we have this, we can say print the hello, right? It's going to print out just hello. But then when we're using the f literal, everything has to be in between the quotation mark. So after the L, we want to print out the name. So what we do is that we just have to put in this name inside a curly bracket. And when we do this like this now, we print out, okay, this has a comma and it's on. So we put in a comma, they print it out literally, and then we can see the different ways to print it out. So whichever one that you're comfortable with, you can actually use that. But this helps when you start having some complex, kind of print statements. So this would actually come in handy. So we see this now. When we put in the variable literally, it actually prints out, the content of the variable, which is hello world. All right, so we have we'll go to the next lesson, which is the strings and strings methods. So like I said, strings are variable data types that actually, created by using your quotation mark. So we can either use this, or we can say we can use a single quotation mark, and everything still works out fine. So when I come here, when I run this code, and remember I said when you come to a new cell and you put a variable name without even the print statement, Python recognizes that variable name and then prints it out, hello. But if you look at this now, the difference is that it prints out the hello even with the quotation mark. But if I add the print statement, it will omit the quotation mark. So these are some of the things we just have to understand. And then to run a cell in your Jupyter notebook, you can actually use Shift Enter or Control Enter. So when you use Control Enter, it stays in that cell. So when I use Control Enter now, it stays in the cell. But when I use Shift Enter, it goes to the next cell. So you can know this, and then it will help. Now we have we have what we call indexing. So there are operations that we can run with string, just the same way we saw some operations that we can run with integers or floating point numbers. So this could be floating point numbers, and Python doesn't care. Python will run it the same way, do everything for you like that. So these are the operations we can run with with strings, that's numeric data type. And but we'll come to string data, we have a string data type. There are some operations we can do with that also. So we have what we call the indexing, which is to actually subset or to get a subset of the string, or to actually get a part of the string, to actually output a part of the string. Like you can take part of the string or take part of the sentence. So when we, and the way we index is that the first index is like the position. So the index of age, that means the position of age here, is 0. So Python must start its counting from 0. So the position of H here is 0. The position of E here is 1. The position of L, the first L here is 2. The position of the second L here is 3. And then this is 5. So this is 4. 0 is 4. So when I want to print out the first this thing, character or the letter in my string, so what I will do is that I will take the greeting and then use a square bracket. And then when I insert the position of the one I want, so it prints out what? H for me. So H is the first letter of this. So when I put 1 here, it prints out he. That's E. When I put 2 here, it prints out what? L. So I can also print a range of letters. So when I start with 0, I can say start printing from 0 up to the second. Now, what happens is that if you, the way Python says this is that it will start printing from the first letter 0 and then count up to one number less than the second digit here. It will start from here and end at one number less than the digit you put here. So it only print out. So it only print out the letters in position 0 and position 1. So when we run this now, it's only print out HE. So, but when I put up to 3, so it will print out what? 0, 1, and 2. The letters in the first position, second position, and third position. So that's 0, 1, and 2. When I do this now, I print out hell. So that's how indexing works. So there are sometimes that you want to actually extract a name from a sentence. A person has written a sentence and you just want to get the name out of it, or you want to person has written a sentence, you want to get the number out of it. So if you know the position of that number, or the position or the range at which that name is in that sentence, you can actually print it out. So let's try that. So if I write here, if I create a new variable and I name it intro, and yeah, your variable is also case sensitive. Now I started with a capital letter I, so I need to remember that, because if I don't put a capital letter I when calling the variable, it's going to flag an error. So when I have this and I want to print out only my name alone, only just my name alone here. Now, so what do I do? So I have to call when I called my variable now intro, right? If I run it, it's going to print out. Okay, I need to run this first. All right. So my name is Peter. So I need to know the position of P and then down to the end. So you don't have to, as long as, okay, there's nothing here again. So if I come here and I say, okay, print, now of course you can count it, but there's a way that we can, there are functions and, ways in Python that you can actually use to find the position. You can even find the name itself, Peter, and it will print it out. You don't have to necessarily know the position. What if you have a very large, document that contains lots of words? So how do you know the position of the name? So there are functions that you can use to find either a letter, if a letter is in a sentence, or if a word is in a sentence. So, but here now we can actually, we have to literally count now. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11. But remember, Python starts counting from 0. So if I want to print out P, I'll have to put what? 12. So when I do this, we print out A. Probably the counting was wrong. So let's try that again. So this is 1. So we have to count the space also. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It does actually 12. So I need to now put what? 13 here. What's going on? So let me see. Okay. So 11 at position 11. Okay, position 11. All right. So when I want to print out everything now down to the end, I will put, just my quotation mark, just the semicolon without an ending statement, and it's going to print out from there down to the end. If I had other things here, it's going to print out from this position down to the end like this. So you can actually, one thing you should take away from here is that what he starts counting from 0, and then whatever position you put here to start from here and end at a position 1 less than the ending position here. So if I put this like this, it's going to end at 14. So from 11 to 14, and I should just repeat. So that's the way you can actually use it. So also maybe you want to print out the last letter of the sentence. So what you do is that you just use -1. So the first letter of every sentence has the position 0, or if every word, then the last one has the position -1. So whenever you write this as -1, it prints out the last letter in that sentence, in that variable. Yes. So that's some of the operations we can. We also have, we have this slice in here that we discussed. So when I run this now, we have Python is in text, so 0 to 3. So it prints out the position 0, 1, and 2. So that's the PYT. And then from 2 down to the end, 0, 1, 2, and then it prints down to the end. So we have other operations that we can actually use in Python in string. So we say this now. Ways, how do we know all of this? So because of course in the course of this class we can't go through all of these things. So whichever variable name you have, so when you come here and you put a full stop, right, and then you press the tab button, it will show you all the things that you can do with a string with a string variable. So when I have the text, a full stop, and then we press the tab button, we can capitalize. We can do the case fold. We have the case fold method. We have the center, the count, the encode, end with, and all. So for example, you don't know what a particular one means. We want to see how capitalize work. So what you do is that in order to, they said when you enter a room, the first thing you should find is the exits. So in case there's something. So now also when you're learning this, you need to know how to get help, how to understand. And then, in Python, it's just literally help. When you just write help, this. So it prints out the documentation for capitalize. So now here you can actually, read up what capitalize can do. So you said help built-in function capitalize now. So it helps us, it returns a capitalized version of the string. So more specifically, make the first character have uppercase and the rest lowercase. So this is actually the duty or the role of capitalize. So this gives you, the edge to actually explore and carry out things. So you can actually find out what all this other, function does by using the variable. So this also works for any kind of variable. So when remember I had a to be an integer variable. So when I put the dot and then I put the tab, I get to see all the things under an integer. So I can find the as integer ratio, the bit count, bit length, the conjugate, the denominator, and all of this can work here. So, and you can read up about any of them at any time. So when you have this, so that's a good way to actually know, because of course we can cover all of the methods, all of the functions that each of these variable have. So, but we're going to cover some of them. So now this clearly tells you what capitalize does. So if I now said, okay, I have this text, or it takes only this, so we may not notice it because already this is already in the capitalized form, as Python has already told us what it is here. So you may want to give it your own meaning, but Python has its own meaning for it. So capitalize now, you might think it's to make all of the letters uppercase, but no, we have a different function for that. So it just makes only the first. So if I have text to be like this, so how can we do something like this? If I have text to be like this, and then I have all of them in small letter, so I have Python, all of them in small letter. So if I run this, nothing happens. So, but when I print, so we see that it's a small letter. So, but then now we now print this text dot capitalize, and then you ensure that you put an empty open and close circular bracket. And then when you do that, it prints out the Python with what a capital letter. So this function has been applied on it. So we have the upper now helps us to convert all the characters to uppercase. Lower now, dot lower helps us to convert all the characters to lowercase. Replace now, you can see it replaces the A with O. And then when we run the output, instead of having apple, we have Oppo here. And then we have we have the dot find. So this is something you can use. So where we were counting, where P was. So if we have used the dot find, let me to find where P is in this. So it gives me the index of P. So P is an 11. So you can tell that, yes, so we started from 11. So we can have, the 11, and then you can print out whatever. So you can find the index position of any letter or any word in a string. So this string could be assigned to, so what this find does, it returns the index of the first occurrence of the substring. So if you have many other E's, it only print out the first E is fine, the position of the first E is fine. So that's the duty of this. So we also have strip. So it removes leading and trailing space. I mean, if there are spaces at the beginning, like here we have space at the beginning, and then we have space here. So if you print out this, my Python will print out anything in the quotation mark literally. So it will print out the spaces at the beginning of this. But when we use strip, it removes any leading and trailing spaces. So for example, you want to, use the variable in the data type. Now let's say we have a name in a variable, and then there are actually spaces. Sometimes you don't know, maybe ask people to input their names and there are spaces there, and you want to actually just get only the name alone and remove any other space that may cause error later. So you can just use the dot strip, and then it removes any leading or trailing space and then prints out only the letters that are in the variable. So we've talked about concatenation. So in the print statement, so also here we can concatenate string together. So when you use the plus variable for for numeric data type, remember it adds them together. But when you use the plus variable for for strings, now what it does is that it joins them together. So we'll call it concatenation. So it joins them together. So we have the first name, this plus concatenation with a space. It literally prints them out, and then we have the last name. So we can, when we have something like this, so we have, let's say, print. We have John. And then we have other like this. So when we do this, it's going to print out John and that without any space. So you can either literally add a space here, like this, or you can concatenate a space together. So you have the double quotation, just space in between, and your addition here. So it can also do the same thing. So that's the plus operator is called concatenation when using it with string. So it joins string together. So it doesn't add them, but just bring them together and then make them into one. So we also have yes, this F string formatting. So we've talked about it, where you can input your variable names in curly brackets and then directly into quotation marks in your print statement. So as long as this F is here, once this F is taken away, it's, yeah, Python will forgive you for this, but because we are using Jupyter here, it knows what you want to do. So okay, for this now, yeah, so it prints out this literally without the F. So it prints out this literally. So everything that is inside the quotation mark now, it does. But when we put the F here now, so it knows that whatever is inside the curly bracket, it's a variable. So it prints out the variable here instead of that. So we have the next data type, which is the list and the tuples. So a list is actually more like a collection of items. So it is ordered and it is mutable. It is ordered in the sense that each of them has a distinct index. So Apple will have an index of 0, banana will have an index of 1, and then cherry will have an index of 0, 1, 2. Yeah, so when we print this out now, this is the output we get. Now, so the way list works, so the reason why we say it is ordered is because when I have another list like this and I say fruits, and it's equal to, okay, let me just get this, because variable names are distinct. So if I just add one here, so this is another variable name entirely. So when I start with banana, so it doesn't say this as the same, though the content is the same. 3 items, apple, banana, cherry. But if I come here and I said it's fruits, remember we can compare them together. equals to fruits1. So Python will tell me false. It is false. That means it is ordered. The first one, for them to be the same, this has to, they have to have corresponding, their elements must be the same and it must correspond. So now if I try this and say it's fruit equals to fruit, that makes true because apple is here, banana is here, banana is here, cherry is here. So that's what we mean by ordered, and it is mutable. I can change it, I can update the list. So when you want to print the content in a list, of course, the same way we print in other variables, we print, and then this can help us. Maybe you want to have the names of students instead of creating different variables for names of students. You can actually create just one variable and write all the names of students inside that variable. So here now we have a list of fruits. So instead of, if we're just only using the normal string, we'll have to create one variable for this fruit one, this will be fruit two, this will be fruit three. But now we have just fruits, and then we have all these three inside of them, and we can access them. Yeah, we can access them. So how do we access them? So the same thing with what indexing and slicing. So we can do that. You make use of the square bracket. So you see that when we talk about syntax, these things has meaning. So a circle bracket, a semicircle bracket now, a circular bracket now has its meaning. So when I want to print something and I use a square bracket here, Python will not accept it because it understands a square bracket to be something different. It understands a curly bracket to be something different. It understands a square bracket to be something different. So all of these things have their meaning. So you cannot just go around using whichever brackets you want or whichever symbol you want. So that's why we need to know this, and then we can actually use it to carry out amazing things. So we want to print out only the first. So we want to print out only the first element in the list. So we just put the square bracket and 0. Python start counting from 0. So it prints out apple. First fruit is what apple. The slice list now starts from 1, which is 0, 1, which is what 0, 1, that's banana, and then starts up to what the one less than this, which is 2. So if you print out, you put 1 and 2 like this, it's print out only banana because it starts from 1 and end in 1 because it starts from 1 less than this. So you want to print out the 2, so you have to add the number. The position of position 3, position 2, so we have to put 3 so that it could print it out. And then we have other things we could do with our list. So now, remember I said there are several things that are in the list variables. So we'll come here, we want to know all of them. We'll come here and say dot, and then the tab, so we can see append, we can add, that's append. Python is actually, remember when I was introducing Python, I said it actually helps us. It's simple and it's readable. So you can see that append, you can actually guess in a way what it means: clear, copy, count, extend, English-like syntaxes, and then we can actually, check for any of these and then use it. So part of the assignment to be to play with some of all these things and then see how it works. So remember we said that lists are mutable, so they can be changed. You can add things to them, you can remove things from them. So when we come here and we say fruit.append, that means it adds this element to the end of the list. So the list now becomes apple, banana, cherry, and what's orange because we've appended orange to the list. So you can also, insert in a specific position that you want to add. You want to add, this now to specific index 1. So you use the variable name, sorry, the function insert, and then specify the position and then the name of the fruit. So when we do this now, we have the name grape now in the second position because remember 0, 1. So if I'd have changed this now to 0, we'll have it as the first. So that's what insert does for us. So extend. So what extend do is similar to append, but slightly different. So what it does is that it adds this whole thing, the list, more than multiple elements, as a single element in the list. So when we do this now, so it adds this now, it has multiple elements. So when we say append, it just adds this just one element to the end of the list. So when we say extend now, it adds them to the list. And then, we can add more than one element to the list. So we can also remove by using dot remove. So all of these are in the documentation, and then you can check it out. So you can remove, so you can specify the ones you want to remove, which is what banana, and then we see banana is gone from here. So it was here before, so we still have the same variable, and then banana is gone. So we can see how we are changing all of this. So pop also what removes the element. So it removes the last element if you don't specify the index. So you can specify the index here, the one you want to remove. So remove, you have to specify the element, specific element, but pop removes the element in a particular index. So when there's nothing here, it removes the last one. So we have list comprehension. So list comprehension is a way of doing something complex in a simpler way using list. So we can use list comprehension for a lot of things. So we'll need to come back to this now when we've actually done our loops, the for loops, the if and the while, so that we can see how this can really help us to achieve a lot of awesome things. So you appreciate it more when you've done the for loop, you've written a code for the for loop, and then you come here and then in one line you can actually do the same thing, still using the for loop, but in list comprehension. So when we have x squared for x in this, so for range now, range of 5 now, we actually have what 0 to 5. So what this does is that for every x now, so that means for every number in that 0 to 5, so this actually loop over it and then square the value. So the square of 0 is 0, the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, the square of 4 is 16. So that's what it does. And then we'll come back to it and talk about it proper. So we can have the sort, we have the sort for list. So you can sort it out, in a particular order, either ascending or descending order. So when we have these, so let's check out what sorts do also. Let's see if there are other things that it could do for us. So when we have numbers now is a list of numbers. So we have this. And then we put it in the help function. So we can see that said sort the list in ascending order and return none. So this sort is in place, so it's sorted in ascending order. So it could also take some parameters. So we can also, now if you don't put anything in this bracket is not just for show. The bracket shows that it can accept parameter because it's a function. So when we say reverse is equals to false, so it will do the opposite. Instead of printing ascending, it will now print it in descending order. So let's try it out. So we can see that, okay, we have a function that automatically prints the whatever thing that is assigned, that is passed to it. It prints that in ascending order automatically, but we can also put the reverse false, and it will do, okay, when we put the reverse true, so we should literally want to reverse it. So it does the opposite. So it reverses, the order. So you want to get in descending order, you want to get in this. So you have to just double the reverse parameter, true or false, and then you have that. So this is why you need to, read the documentation and then try things out. So we have the reverse. Then we have our tuples. So our tuples are actually what? They are ordered and immutable. That means you can't change them. So we saw where in the list that we can actually add things to the list. We can subtract things from the list. We can actually change the list and all. So, but for this now, for the tuples, we can only create a tuple and we cannot change anything in the tuple. So we can only print things out and then that will be all. So now, so let's see how some of these functions we can carry them out on a tuple. So now when we have this, we can print out, you can also access the list, access elements in the tuples by using your square brackets also. So the same thing with lists. So list and tuples are similar. The only difference is that you cannot change the elements in a tuple, but you can change the elements in a list. So we want to print out the last element, we use -1 and then we print it out also. This is very familiar to us. So all right, we have this. We can actually unpack the element. So what we call this, we can multiple assignment of variables. So we remember, let's just go back a bit. I talked about assignment of variables. So you can actually say a is equal to 10, right? Assign it. So if you want to assign multiple variables in one line, so you can use a comma. So we have a B, and C. So if you have to now put a comma here, and then you have 10, 12, and 13. So now it has assigned 10 to A, 12 to B, and then 13 to C. So when you go to another line, and then you print out B, you print out 12, and you print out C, you print out 13. So you can actually assign. So this is just a way of telling you that, okay, it's possible to do multiple assignment of variables in one line. So we can unpack this. So that's the idea here also, that you can unpack the tuple into different variables. So we have ABC. So we already know what our variable contains, 1, 2, 3. So we put the same number of variables here. So when we assign it to the tuple, so what it does is that each of those number is now assigned to what the variable. So when we run this code now, we see that what A now has a variable 1, B has variables 2, and C has variable 3. So we notice something that I've been repeatedly using a kind of variable. I've used A like up to 3 times now. And Python, you can reassign a number to a variable. So I assigned 10 to A initially at the top. I assigned A not too long as 10 again. And then A now is 1 here. So if I come here and print A, is the last digit that was assigned to A that we printed out, which is 10, if this is 1 here. So if I run the cell where I said A is equal to 10, if I run this cell where A is equal to 10, and I come here to print A now, it will be 10. So you can actually update the values in a variable. So we have exercise here, which I'm going to give to us, so you can actually create a list. Remember how you want to, whenever you want to create a list. So whenever you want to create a list, you have to use the square brackets. So automatically, when you put in whether anything you put, any list of numbers you put, or any range of numbers you put inside square brackets, that was square bracket, and it's square bracket, Python knows that this is a list. So you can easily create a list. So why for strings, put it in quotation marks, starting and ending. For integers, just write the number there. Then for tuples, we see that when you use circular brackets, that's the semicircle bracket and circular brackets, so Python sees that as a tuple. So also you can also just let's say for example I said height, and then I say 1,2,4. So let's just say this is height now. So I didn't put any code bracket. So let me find out what type of variable it is. So remember, you can just write your type. So this is also a tuple. So you don't have to necessarily put the brackets, the circular brackets. If I say create a tuple now, with your name, your age, and your city, so you can just put your name, comma, your age, comma, your city, and Python says has to be a tuple. So you can also put the brackets, and that would also still be fine. So, but for good practice, it's good you put the brackets. So I also said, okay, the first exercise, create a list of your favorite movies and print out the first movie and the last movie. You know how to do that by now. We also have to write a program that takes a sentence and print it out in uppercase and lowercase. So you should know the function. So when assign a sentence to a variable and then print it out in uppercase, the function is there. We use it also lowercase, the function is there. So create a list also of numbers 1 to 10, and then use list comprehension to print out. So you could leave this because we didn't really talk about this, but you can also try it out. Very, very, very awesome exercise to juggle your brain. So we have create a tuple with personal information, your name, your age, and your city, and then print each element out. So we see where we can actually unpack a tuple. So that's good practice. Then we're still on list. Okay, this is actually like the exercise. So I'll take this out before sending it to you. Okay, so for today, we've come to the end of the class today. So feel free to ask any question. Is anything bothering you? Anything I've said, and then you can ask a question now. It's time for questions.